Hello, everybody. I'm pleased to welcome you to this webinar with the focus, the rules and challenges of building large metal AM parts. My name is Dovan Bazik. I am Product Marketing Manager at GF Machining Solution, and I'm in charge of our metal AM system. During the first 5 minutes of this webinar, I will briefly introduce you to GF, and I will also share with you some inputs related to the customer of large metal AM parts. Then I will give the floor to Francesco Maia. He is an application engineer working on additive manufacturing, and Francesco will share with us the key and unique rules and challenges when it comes to print large metal AM parts. He will also present how to overcome these challenges. Then Marco Salvisberg, which is in charge of business development for additive manufacturing at GF Precast, will present the AMotion Center, and he will also share with us interesting case studies in relation with energy and aerospace industries. At the end of this webinar, we will have a live Q&A session. So I invite you to write your questions using the GoToWebinar box, which is on the right side of your screen, and we will come back on these questions at the end of the webinar and we'll try to answer them. If you miss anything during the webinar, do not worry, this webinar is recorded, and afterwards we will upload it on our website, gfmsadditive.com. You can also download the relevant brochures and white paper during the webinar by also clicking on the GoToWebinar box on the right side of your screen. Thank you for taking the time to participate to this webinar. I'm looking forward to read your questions and try to answer to them. Now I will switch off my camera and I will start to present the slide. So first of all, GF Machining Solution is one of the 3 divisions of the big group Georg Fischer, which is a Swiss group, where you have once again 3 divisions: GF Piping System, GF Casting Solution, and this is very important in relation with our role in additive manufacturing, and obviously GF Machining Solution. GF Machining Solution is a Swiss company. We are headquartered in Biel. We have around 3,000 employees worldwide, and in 2019, we achieved a revenue of approximately 1 billion Swiss francs. In the machine tool industry, we have acquired unique technology portfolio with solutions in milling, EDM, laser texturing, metal AM, obviously, micro machining, spindles, tooling and automation, and digital transformation. In the field of AM, thanks to our partnership with 3D Systems, we can offer a complete solution to the production of metal AM parts. This offer is basically built around the core printer technology with the DMP printers, for which a robust database of materials and parameters has been developed. The printers are complemented with a high-end software named 3D Expert, which has been developed by 3D Systems. GF, we strongly focus on the integration of the technology into the manufacturing process chain, into production, with strong links to post-processing, post-machining. And for that, we are using the product developed in terms of tooling, as well as dedicated post-processing solution like dedicated wire EDM solution for the separation process of the 3D printed parts. Finally, we have a global team of application experts that can guide customer in the adoption of additive. In terms of printers, we are using the laser polar bed fusion technology in our machine. We have the 3 printers, the DMP Flex 350, the DMP Factory 350, and the DMP Factory 500, which is the most interesting machine in relation with the topic of today. It's our large machine. The print volume in this machine is 500 by 500 by 500 millimeter, and we have 3 lasers inside this machine. An important point before to start, in this presentation and in the different topics that we will address, we will focus on the printing process of single large metal AM parts thanks to large machine, and not on multiple parts production with large machines. So we will focus once again on single large metal AM parts production. In terms of markets, what we can say is that with a more mature technology, let's say, and further adoption of additive in all industry, it's quite natural then that company wants to produce large metal AM parts. But this is also possible thanks to a new offer in terms of printer, in terms of, for example, build envelope, and we have seen that with the DMP Factory 500, but also in terms of the number of lasers that we have inside the machine, and also, for example, in terms of improvement of the software to manage this laser. Productivity increase is a must then to reduce the cost, and this is a must in order to produce, you will see, large AM parts. The key industries for large AM parts are aerospace, obviously, and specifically engine components or the production of engine components, energy, and mostly in relation with industrial gas turbine, oil and gas with valves, for example, and finally in the transportation industry and specifically on rails. What we can see in terms of shared attributes of customer or user of the technology is the same conventional process, or the parts are produced with the same conventional process. Can be forging, can be investment casting, and this is a picture which has been taken in GF Precicast, can be milling or can be welding. We can see also a shared attribute in terms of importance of materials. When you print large parts, the amount of powder that is required is much bigger than with mid-size machine. It means that the investment in this powder is important. So the user, the customer of large machine, they want to master the complete supply chain of materials because of this big investment. And these concern the specification, these concern the supplier, and of course the quantity. One important point also is that AM for large part must give an advantage in terms of cost. It cannot be only related to the functionality. It's always, the decision will be always related to the cost per part. What we can see also with our customer that wants to invest in a large machine, they need further support than with a mid-size machine in terms of consulting, in terms of qualification, in terms of serial production, starting, etc. But Marco Saviliba will come back on that topic later on. The key recognized benefits of additive manufacturing for large parts are very close to what you can do with mid-size machine, but they are even more important. They're related to assembly consolidation, performance and quality. And here I'm referring also, for example, to density. If you think about previously casted parts, lead time reduction, you can drastically reduce the lead time in the production of large parts. Digital outsourcing, digital production and back sourcing. So as a first conclusion, but also as an introduction to the next topic, we can say that large machines are on the same path that mid-size machines were a couple of years ago, with a shift from prototyping to series production. But there are some specific challenges when it comes to build large AM parts, and this is what Francesco will present to you now.
Thank you, Don, for this nice introduction of yours, and let me say hi to all the people out there in our audience. So in this section, we will have an overview of the different challenges that users in the different sectors are nowadays facing as they look into building metal AM parts that are bigger and bigger in size. So what you see listed here is a list of challenges indeed that are typically mentioned by the final users in the markets that we presented before. These are of course confirmed by us as together with our partner 3D Systems. We are developers of the technology and its related systems. That's the first of it. In our opinion, these challenges may be grouped into different categories. So we have first group that is made by those challenges that are existent with small to medium sized parts and just scale up with large parts. In this case, we as users may be already familiar with them and have the right mindset to tackle them. Vice versa, we have a second group that is made by by those challenges that are typically not existent with small to medium-sized parts and appear or arise when dealing with large parts. And in this case, it's a whole new world that opens up before us when approaching big size parts. And this is where innovation really originates from and plays a big role in helping address those challenges. This distinction is important as it explains the kind of effort that is required when trying to switch from small and medium-sized part production to big-size part production. And as I said, we first looked ourselves at this list with the eyes of a final user, which we are indeed to some extent, when we decided together with 3 systems to look for and develop solutions to such challenges, as you will see later on in this session. So we start from job preparation as the first challenge. And in this regard, what is really needed here is a high expertise in developing parts for AM, starting at the design stage and then going into the part orientation, supporting and generation of the build scanning strategies that are applied to it. The bigger the part is, the more each of these items makes a difference in terms of part quality and cost, as well as process reliability and performance. To this purpose, what is also very important to have available is a set of process parameters that have been fully tested and validated through an extensive research, development, and testing work on the AM system selected for the parts to be produced. As a last point, when dealing with large parts with long build times, you can imagine how big of an impact a scrap part or a job failure have on the overall process yield. Therefore, it's really necessary to avoid multiple trial builds on the AM machine and rather move all that trial and error work to the virtual level. Then comes the need for dedicated software tools that allow to simulate the AM process and thus iterate on different design and build conditions before going to the machine for a first time right part. Then we go into build volume. Of course, here the first challenge is to be able to fit the part we designed, not only inside the build envelope of the AM machine, but as well inside all the ancillary systems that we selected for the post-processing of the part as it exits the AM machine. Then with large build volumes, 2 additional challenges come. The first one is the management of high amounts of powder that are needed to build such big parts. And very important, this has to take place with no degradation and no waste of the metal powder. Many of you will already be familiar with the whole metal powders for AM world, and you will know that these powders are of really high value. So they really represent an invested capital when they enter the manufacturing facility. Therefore, the role of the AM machine and all the ancillary systems is not only to turn that powder into full solid material, but also to preserve the original quality of that powder with no waste, in order to be able to recycle it for the following jobs. A second direct consequence of large build volumes is the weight of the AM parts that are built and the weight of the build platforms that are needed for such builds. Just to give you some figures here, for a large build, we easily have above 100 liters of powder that need to be managed at once. And you can imagine the high value of that amount of powder. Then depending on the metal material that is being used, this 100 liters of powder mean a weight of between 150 and 500 kilograms. Then we have parts and big parts, as we intend them, can range from few tens of kilograms to above 100 kilograms. Lastly, just to provide a reference with our systems, a standard build platform made of steel with dimensions of 500 times 500 times 50 millimeters in thickness weighs around 100 kilograms. So out of these figures, you can really feel how important it is to have dedicated automated pieces of equipment that do the work for us and replace all the manual functions that are traditionally carried out when dealing with small and medium-sized parts. As a third challenge, we have build time. And to this regard, we all know that no matter the ways to increase the productivity of machines, we always talk about a slow process if compared to other manufacturing technologies. And this build time grows together with the volume of the part that we intend to build. Just to give some numbers here again, for small or medium parts, we talk about few hours to a couple of days to have our part built. While for large parts, we talk about few days to about 1 full week to have our final part. So when dealing with build times that are this long, you can really understand how important it is from a cost point of view to minimize risk and scrap rate, as we already discussed. And to achieve this, what is needed is a high process stability, which comes when the process and the machine are fully tested and calibrated. And then we have a high reliability of the AM system, which is definitely easier to achieve if the system is conceived and architected in a way that is smart, together with all its ancillary pieces of equipment. For what concerns machine productivity, we should all already be familiar with the fact that the trend nowadays to increase the productivity of machines and big size machines especially is to switch to a multi-laser configuration where multiple split the work and act in parallel on the powder bed, thus reducing build times. On top of this, such multi-laser configuration needs to be smart in order to allow for a thoughtful management of the balancing between different lasers and the overlapping of adjacent regions that are scanned by different lasers. This way we can avoid a processing condition where productive time is wasted, and this is the case where our lasers are not properly balanced, and thus for every layer, one or more lasers stay off, waiting for another laser to finish scanning the region that is assigned to it. Then as a second point, in the case of improper laser overlapping, these uniformities on the part surface may arise at the junction between regions scanned with different lasers. And this result in a poor quality of the final part. As a last need that really targets machine productivity and efficiency, we have the need for automated routines for machine calibration, which can really shrink the downtime of machines associated to their calibrations, as this kind of operation is typically performed in a manual way. Then we go into post-processing operations, and this is something that is really perceived as a challenge nowadays by the majority of users, a challenge that becomes tougher and tougher to overcome as parts get bigger and bigger. Out of this, you will understand how important becomes the need for a holistic approach to the additive manufacturing production, and such approach since the very beginning has to take into account the IM stage as well as all the subsequent steps that lead to the final part. And this can only be achieved by combining hardware and software together. For what concerns the hardware specifically, we have then the need for post-processing equipment and tooling that are conceived to be integrated in a full production workflow with seamless transition from one stage to the other. And from this comes the list of subsequent challenges that you see here. First of all, the preservation of reference points on parts as they exit the IM machine and move to the following post-processing steps, together with the full compatibility between machines and post-processing stations. Then an operation that is always necessary for IM parts which is the separation of the part from the build platform. An operation that is of great importance and that becomes more and more demanding as bigger in volume and weight, and thus requires a dedicated solution to perform it. And then as a last point, there is then the need for a set of solutions for the post-machining of parts that have a very high degree of flexibility in order to be able to process all the different shapes and geometries that we can get out of the additive machine. Then, as already mentioned by Doan, we have some challenges regarding the cost effectiveness of the technology and its related systems. This is something very important as up to now we've spoken about technical challenges, which definitely need to be overcome. But at the end of the day, a technology can be implemented at production levels for industrial applications only if it proves to be cost effective. In our opinion, and I can say understanding of the different users and sectors, cost effectiveness can only be achieved through systems that can precisely fit to the specific needs of their users. And from this comes the need for a modular design of the AM system that can be scaled in order to meet such specific needs. And then you see listed two indicators that are very commonly used for evaluating the performance of a system in a production environment. We have the total cost of ownership, TCO, which we want to be as low as possible, and the overall equipment effectiveness, OEE, which we want to be as high as possible. And then as a last point, we have productivity and ease of use that are named here. And they are named as major challenges to overcome in order to achieve low unit costs of the final parts, which down the line is what the majority of users care about. Here with productivity and ease of use, we don't only refer to those of the single machine or piece of equipment, but rather those of the overall production workflow. And this can only come with the optimal workflow where all the single steps are well linked together with a smooth, seamless transition between them. Okay, so now that we've seen the challenges that nowadays exist to the production of large AM parts, we would like to spend a bit of time showing how GFMS has addressed and solved such challenges. For what concerns the need for high expertise in carrying out design and preparation for AM, GFMS can put at the disposal of its users and customers several years of experience in using and developing the technology together with our partner 3D Systems. Such experience mostly come from the wide network of centers of competence that we established around the world, where we constantly challenge our machines and technology for developing projects for customers, as well as from our partner AMotion Center, as we will see later in this session. All of this makes us ready to transfer such knowledge and expertise to our customers. This way, helping them heavily cut the time it usually takes to implement a new technology into a production environment. Of course, in order to be able to apply such expertise to real parts, we need some tools. And one of the most important tools for us is 3D Expert software, which allows users to manage the whole software workflow for AM parts in one single CAD/CAM environment to simulate part builds by AM, thus avoiding multiple trials on the additive machine, as we discussed. What we also offer together with our systems and software is the laser form materials, which come, of course, in the form of virgin metal powder. But on top of that, each material is offered together with a set of process parameters that have been fully tested and validated through an extensive R&D work of months or even years. This again puts our users in a position of really having a turnkey technology that is ready to be adopted for industrial part production. Then we spoke about build volume, and here we get a bit closer to our DMP Factory 500 system and its features. This machine, as we said, has a build volume of 500 times 500 times 500 millimeters, which is one of the biggest build envelopes today available on the market, and really solve the challenge of fitting big parts into it. For what concerns the challenging management of very high amounts of powder with no degradation and no waste, we would like to highlight the vacuum chamber concept of this machine, which has already proven very effective in this regard on the well-established medium-sized machine of our portfolio, the DMP 350 machine. And then as a last point, together with the management of high amounts of powder, we've spoken about the need of handling heavy parts and build platforms. And to address this topic, you see pictured here the whole set of ancillary systems that are conceived to be operated together with the DMP 500 machine in really a factory setup. Each of these modules is conceived for a function of the AM production cycle. You see we have a module dedicated to the powdering of the build part, a module dedicated to the recycling of the powder, and all of these modules are connected together by a removable printer module that you see inside the AM machine. This module is really the core of this factory solution, as it contains all the metal powder and the part built inside the AM machine, and it travels from one station to the other in a very flexible and scalable setup that allows to manage those volumes and weights in an automated and very user-friendly and also safe way. For what concerns the process stability, we've spoken about the laser form materials that come with a fully tested and validated set of process parameters. And this really goes into the direction of a stable process for production purposes. On top of that, we listed here two features of the DMP 500 machine that are really meant for having a stable process. An optimized gas flow across the powder bed, which is really important for the metal powder bed fusion technology. And then the possibility to clean the laser window while the process is running, as a dirty window can really have a huge impact on the process stability. For what concerns system reliability, we name here once again the modular setup of this system, as inherently increases the overall reliability of the equipment, since each module is designed for a task and it is running as a standalone. So we don't incur in the case of one function is down, the whole system is down. That is typical of configurations where multiple functions are combined together in one single device. Regarding the machine productivity and efficiency, we spoke about multi-laser configurations as the way to increase them. And then we also spoke about the need for a thoughtful management of the laser balancing and overlapping. In this regard, the DMP 500 machine has a unique optical configuration with 3 lasers, which you see pictured on the right. You can see that this machine has 2 lasers, laser 2 and laser 3, that cover 2/3 of the build platform each, plus 1 laser, laser 1, that covers the whole build platform. And this system is, of course, targeting a higher productivity with 3 lasers that simultaneously act on the powder bed. And it can be properly managed in the multi-head environment of 3D Expert in order to achieve a very good management of the laser balancing and overlapping in an automated way. Having a full field laser that can access each point of the build platform also makes possible to scan the contours of the whole part with 1 laser only, thus avoiding discontinuities and seams on the part surface at the interface between two adjacent regions that are scanned with different lasers, as it happens very often with other optical configurations. As a last point that we would like to mention here is regarding the accuracy of the machine. And this is the automated scanner calibration routine that allows to perform the calibration scanner heads in an automatic way. That's really cutting down the time it usually takes for operations of this kind, as they typically require manual steps to be performed. For what concerns the post-processing operations that are required after an AM build, we highlighted the need for a holistic approach to the AM production that combines hardware and software together. As we already discussed in terms of software, 3D Expert is for us the tool that makes this possible, as in one single software environment, it allows us engineers to move from the CAD model of the part to the job file that we send to the AM machine for printing, as well as the CNC program that we send to every other machine for finishing operations on the part. This workflow takes place through a series of different steps that you see pictured here, through which the part is first prepared and then optimized for additive manufacturing, as I said, in the very same software environment. On the hardware side, we highly stress the need for post-processing operations, post-processing equipment and tooling that are conceived to be integrated in a full production workflow that starts from the AM machine and finishes with the final part. On this basis, we listed some challenges that users are facing nowadays when trying to set up such production workflow, especially with large AM parts. GFMS has been working for quite a long time on this holistic approach to the AM production, and together with the DMP machines, it's nowadays capable of offering solutions that make such an approach possible, and thus solve the challenges that we listed here. First of all, we have a set of dedicated System 3R tooling, which allows to transfer the part from the AM machine to all the other post-processing machines with full intercompatibility, while preserving the reference points on the part. And then we have a dedicated solution for the separation of parts from build platforms. And this is an operation that is very challenging when we deal with parts and platforms of large dimensions and weight. This solution is the CAT AM 500 machine that you see pictured here. This is a wired EM machine that was specifically developed for this function, and it has a unique horizontal cut technology for this, and can of course accommodate the large parts and platforms exit the DMP 500 machine. As a last point, we have, as mentioned by Doan, a wide family of milling, die sinking, and wire DM machines that really complete our technology portfolio and allow for a flexible part finishing. Now we get into the list, which is the cost effectiveness of the solutions adopted to build large parts. And regarding this challenging and how to address it, we've spoken about the need for systems that can precisely fit to specific needs with low TCO, high OEE, and the highest productivity and ease of use possible throughout the whole production workflow. Now, in this regard, I would like you to recall the modular architecture of the DMP Factory 500 system with its ancillary modules. With this architecture in mind, you can really understand how all of this becomes possible, as the different modules can really be combined together in a configuration that suits the specific needs of a user. As a direct consequence of low TCO, high OEE, and high productivity and efficiency, we have a low cost per part, which, as we discussed, is really what makes the difference for a sustainable business at production levels, particularly when dealing with parts that grow bigger and bigger in size compared to what we have been used to in the past with medium-sized machines. With that said, I got to the end of this section, so I will give it back to Don for the following one. Thank you.
Thank you very much, Francesco. Thanks for this explanation and how we can overcome these challenges with our solution. I will give now the speech to Marco Salvisberg, who will present you the AMotion Center, and once again, very interesting case studies related to energy and aerospace. So the floor is yours, Marco.
Thank you, Doan. So during the next 15 to 20 minutes, I'm going to talk about the offering of the AMotion Center Switzerland, and I will show you two examples of customer project that we realized this year. So at GF Casting Solutions, we have 200 years of history of producing metal parts. As of today, our main markets are automotive, energy, and aerospace. We have 4 different technologies available, always fitting to the needs of our customers. So, for example, aluminum and magnesium high pressure die casting for automotive, iron sand casting for industrial applications and also automotive, precision casting for aerospace and energy, and additive manufacturing for all of them. So before I enter the additive manufacturing part, I wanted to tell you why we have started with AM. So what you see here is GF Casting Solutions Novazzano, formerly known as Precicast, so a investment or a high-class investment casting foundry located in the south of Switzerland. Several years ago, the customers of this foundry, so the OEMs from aerospace and industrial gas turbine business, approached the management saying that some of the parts that they were casting in these days will be transferred in the future to this new technology called additive manufacturing. And luckily, the management decided now 5 years ago that they will heavily invest in additive manufacturing in order to supply the best possible solution to their customers. So what was the idea behind producing AM parts as an investment casting foundry? Having all the knowledge about the production chain already in-house. So I speak about all the metallurgical know-how this company built up during 50 years of producing parts for these markets, the strong collaboration with the OEM customers, and the existing and qualified competences and resources already in place, managing all the steps that are needed after the casting. So heat treatment, HIP, finishing of surfaces, Q inspections such as X-ray, CMM, or whatever else is needed. So now the idea was we keep the casting route, but we open a next production route. So take out of the existing supply chain the qualified alloy supplier, put in the qualified powder supplier, take out the capability to cast and put in the capability to print, but the rest remains the same. And this enables us from the 3D printing side to supply parts out of a fully aerospace and energy certified supply chain. So our offer in additive manufacturing, we really start with consulting and training. So this means we screen the part portfolio of our customers, or we help our customers screen their part portfolio, and we help them to find the right application to start with additive manufacturing. So there, my job is mostly to say no to application, because where we don't see the potential to lower the cost or to bring additional advantages, we don't want to start the project. Once we have found the right project, we help the customer to adapt the design, so to make it feasible for additive manufacturing, or even to change the design completely for additive manufacturing, taking into account all the possibilities thanks to this new technology. Once we went through these 2 steps, we have printers available, and we can print within few weeks or even within few days the parts developed or discussed before. So this enables us to give a prototype part to our customer, and the customer can test this part. Then next step is part qualification. As I said before, with 50 years of experience of producing critical metal parts for aerospace and energy, we have a new knowledge how to apply customer specification, or even how to write them, adapt them to additive manufacturing. So we support our customer also with this knowledge. And then obviously we are running serial production for several customers. And as of today, 35% of our part portfolio are parts that we supply ready to mount. This means included machining or even some surface coatings. So as I said before, post processes are key in this business. So as I don't want to go in detail here, but all these lists you see here are post processes we have in-house. So this enables us to be, on one hand, really fast if necessary, because we don't have to deal with several suppliers going out, for example, to do a heat treatment or to test the part, to airflow test the part, for example. And on the other hand, it lowers the cost because we don't have to handle suppliers and everybody's putting a margin. So it's everything under one roof. And as I was speaking before, everything out of a certified supply chain. And what means certified? So this means it has to be certified. Oh, what means whole supply chain? It has to be really from the beginning certified. So this is why since 2017, we have the ISO 9100 and ISO 9001 certification for our additive manufacturing plant, which allows us to design and develop and produce parts for our targets markets. And furthermore, since 2018, we are one of only 6 companies worldwide holding the NADCAP accreditation for the special process additive manufacturing, enabling us to supply parts to our aerospace customers. So now to the most interesting part of the presentation, and I have first to apologize that the pictures you will see will be quite small, and they have the GF logo on it. This is because, as you can imagine, our projects are all IP critical for our customers, and I'm happy that I could convince 2 of them that we can show their parts. And furthermore, I had to promise that we hide the critical features of the part. But nevertheless, I think the message will be transported. So first project out of the energy sector. Early this summer, this customer approached me and said, Marco, I have a problem. I have a test bench ready in 3 months, and I need all the raw parts, so 4 different raw parts within 2 months. So as you can see here, 4 of these parts. These were the parts that the customer was requesting. He said to me, look, all the current technologies I'm normally using, so investment casting, sheet metal forming, or weld assembly, are supplying or are offering lead times. They are way longer than the 2 months I have. So I said, okay, with additive, we can do it. And if you have a look now at the weight of these parts, the lightest one has 10 kg, which is already heavy for an AM part, and the heaviest one is 32 kg. So you see the range of weights we have here. Furthermore, also the size is quite impressive. So the highest one is 420 in the Z-axis, and the widest one has a XY dimension of 500 millimeters. So what were the benefits using additive manufacturing? First of all, the lead time. So the customer told me that all the other processes are offering lead times that are more than 6 months, and he had 8 weeks. He had a maximum of 8 weeks. So we managed to supply the first part 10 working days after he placed the PO, and the last of this part, which is was in this case the burner cover, 6 weeks after he placed the PO. Then in order of cost, because there was no tooling needed and not many development iterations were needed, he told me after the project, unfortunately for me as a sales guy, that he could save 75% of the overall cost, which is amazing that we could deliver this benefit in cost to him. Also, I'm having some margin on our side, obviously. And then flexibility. So I told you that we started with printing the strut, and his team was working on the next 3D model, so the 3D model of the transition support, until one day before we have to start the printing. So this means we gave him, for the last component, which was the burner cover, additional 4 weeks of engineering time. Furthermore, now in the second generation, he don't have to buy additional toolings or something. So we only have to adapt the 3D models, our build jobs, and there is no additional cost for him printing further parts with slightly other geometries. And then the part that, let's say, amazed me the most was the performance of the component. So I remember during a conference call where we discussed the supply of the transition support, he tried to lower again or to cut again the lead time for this part. He said, no, I have a problem because I have to send the transition support to a sub-supplier who will do drilling, so deep hole drilling and laser drilling of cooling channels. And I said, no, it's not possible. The part is on the printer. The print time is set. We cannot speed up now. This is there is no space for improvement. But I said to him, but why you are not printing directly the cooling channels? So why you're not implementing this action into the printing? So he was not aware that this solution is existing. And afterwards, he applied, with the help of our engineers, cooling channels that were not only straight as he was planned to apply before. So he applied cooling channels which were near net shape. So this increased the performance of the part, and he added value to the printed part without adding cost. So this was really highly appreciated by him. Then 8 or 9 weeks after we finished the project, we delivered the last part. He called me and he said, Mark, I want to give you or I have to give you a feedback about the part. So I was already worried because giving a feedback normally is something negative, that something went wrong, what I was used for my previous life working for casting. So but he came and said, look, I'm amazed about this technology, because the density of the part was higher than he was used for investment casting. The tolerances were way tighter that he was used from investment casting and sheet metal forming and weld assembly. And the machinability of the part was way better than he was used from investment casting. So he said this for him was a perfect project, and the fact that he has already done since summer 2 other projects with us means that this technology has fully convinced this customer. So now going to aerospace. Here the task was to develop and produce a new generation of a front frame for an aero engine. So, and here, please take a look only at the dimensions of this part. So we have 490 times 560 times 300 millimeters. Now you say, okay, but Francesco told us before that the machine is 500 times 500 times 500. So how does this fit? if you have like a square as we have with this 500 times 500, you have in the diagonal, so 500 times the root of 2, and you have the diagonal of 707. So this means in the best case, and if the part is developed or designed in a certain way, you can print on these machines parts with a maximum diameter or with a maximum length of 707. This is why here in this case, and here are the pictures, you can see in all of the pictures, you can see that there is a flange going with this 560, but the rest is fitting into this 500 times 500 without using the angle. So if you have also a look at the weight of the part, we are here at 55 kg, and this is only part weight. So imagine the weight of the part, including the supports. The material used was Inclus 718. So what were the benefits using additive manufacturing for this part? So first of all, lead time reduction. They asked their supplier base and investment casting to develop this part. And the best lead time they got was 12 months. And we were able in additive to deliver the first functional prototype. So the first prototype that was tested on an engine testbed within 10 weeks. Then cost reduction. According to them, the cost we offered compared with the best cost they got from investment casting foundries was on development cost 85% lower, and on series price was 20% lower as the offered average price of the investment casting foundries. Because this part is so complex for the process of investment casting that the cost is shooting through the roof, and with additive manufacturing, we can be way more efficient than these guys. And then obviously also here the flexibility. So we have now printed several of these parts, and they are changing the design between each iteration. And guess what? The cost is not going up, the cost is going down, because these guys are applying our suggestions for adapting the design to additive manufacturing. So we got rid of a lot of supports, for example, which lowers the price of the part. And then again, the performance of the component. So the customer let's say in the more advanced models, insert also here near net shaped cooled channels. They ask us or they in one call said, but can you add a flange here? Can you add a bumper there? Can you remove material here in the inner cavity? Can you add cooling channels? And for all these questions was always yes. So also here, this customer added a lot of functionality to the part whilst lowering the cost for the part. So this was only a short presentation about our capabilities. The team at the AMotion Center Switzerland and myself are really looking forward to discuss with you guys your ideas, and I'm sure that we will develop together applications which will move the boundaries of what is feasible quite in an important way. So thank you for your attention, and looking forward to answer your questions.
Thank you, Marco. We have a couple of minutes left before to end this webinar, so I would like at least to have 2 questions for each of you, and I would appreciate if you can answer to this question with a quite short answer, if I may say. Francesco, I have a first question for you.
Yes.
Do you believe there is a fundamental different approach when printing very large parts versus small or mid-sized part, if I may say?
I would say that the approach is the same. As I said, in terms of part development, as we said, the challenges that already exist with small and medium-sized parts, they just scale up with big-sized parts. So we really need to do everything that is possible to minimize risk and really be sure when we go to the machine, because long build times mean costs for manufacturing facility, and the failure is really weighing a lot on the overall accounting. No, so deformations, thermal problem, the recoating. These are all items that we consider when we process a part, when we prepare a part, that just need to be taken into account with even more attention and even more knowledge and expertise of the process and the machines that we're using.
Okay, thank you. And another question for you:
Yes.
Is there a difference in quality that you see between mid and large size platform?
If a machine is well calibrated, I personally would answer no. Let me expand this a bit. What we, as I said, what we deliver together with the machine is a fully tested set of parameters. So this means a lot of testing. We go up to 2,000 the data points for a laser form data sheet that we deliver. Of course, there you find the averages, but all of this is really averaged on a lot of points, testing points, and this really translates into part quality. So for a well calibrated machine and a fully tested process parameter set and process that is ongoing, the quality that we're able to deliver is the same.
Understood. Thank you, Francesco. And two questions for you, Marco. The first one would be, which are the materials that you believe are the most interesting for the production of large AM parts?
So for the moment, we are running our printers with nickel-based alloys. Why nickel-based alloys? Because this kind of alloys are quite hard to process with other technologies. So you can cast them, you can forge them, but this linked with a lot of problems. This is why we decided to process at first nickel-based alloys.
Okay, and the second question would be, can you give me an example where you do not recommend to a customer to use additive and why, or to not use additive and why?
If a part is perfectly engineered for casting, for example, it does not make sense to investigate additive unless the customer needs something really fast. But if the customer has enough time and is accepting the limits of casting, for example, then I would never suggest to use additive, because if the part is perfectly engineered for casting and there are no problems and the part is performing well, makes no sense to enter in a new technology. But if the customer wants to further improve a part, pushing the boundaries of what was feasible, what is feasible and what's not feasible, he has mostly to change technology. And this is then when I would suggest to change also the technology from the, let's say, the traditional one to a new one.
Okay, thank you, Marco. So we are arriving at the end of this webinar. I would like once again to thank everybody that took the time to participate to this webinar. Once again, you can download relevant brochures and white paper directly on the GoToWebinar window, but you can also find all this material on our website, once again, gfmsadditive.com, where you will be able also to discover in more detail our printer, our workflow approach, and also the recorded version of this webinar. So thank you very much. Please do not hesitate to fill a form on our website if you want to meet or to get in contact with Francesco or with Marco Salvisberg. Please do so. So thank you very much. I wish you a nice day, and I hope to have you once again in the next webinar that we will hold. Thank you, Francesco. Thank you, Marco.
Stay safe.